Okay, welcome back to another video. Okay, we know that it's been a long time, but I figure it will be a good way to start the year with a integration question. Let's go. So today we'll be practicing trigonometric substitution, and we'll do it with this problem right here. So let's rip it apart. Okay, so using the substitution x equals a secant theta, show that the integral from a root 2 to 2a of dx over x squared x cubed times the square root of x squared minus a squared equals 1 over 24a cubed times 3 square root of 3 plus pi minus 6. Now, normally, if you're given this type of problem, you would have to figure out yourself what would be a suitable substitution to make. But here, they actually give you the substitution that you're going to need. And that makes matters a lot easier. So the first step is to make the connection. So first thing we need to do is transform this integral into the world of du instead of dx. So the first step is to have x equals a secant theta. And we're going to take the derivative with respect to theta. And we would have dx and this is one of those standard derivatives that you're required to know. I will provide a link in the description. This turns out to be a secant theta tangent theta, and so therefore the dx and right there we just transformed this integral into the world of d theta instead of dx. Now, if this was for indefinite integrals, we would be done. But remember that for definite integrals, we must change the bounds of this integral as well, right? Because right now, the bounds represent the bounds for x, and we need to change it to the bounds of theta. So we're gonna do something called change of bounds, and the way we do that is that we would have so the upper half 2a equals a secant theta. And so by doing that, we find that 2 is equal to secant theta. And so cosine theta equals 1/2. And theta is equal to pi over 3. And you would do the same thing for the lower bound. So the lower, we would have root 3, and you would have cosine. And this is directly comes from our special triangles. Same with this, we get that theta is equal to. So therefore, we can make all these substitutions and transform our original integral here. So therefore, the integral going from 2 to a x squared minus a squared. We make the substitution. So now that we've got our respective parts of the integral, we can put it together and rewrite our original integral here. So this would then be instead of a square root 2 and 2a, we change it into the bounds of theta instead of x. So these are actually our new bounds here. So that'll be, let's go going from pi over 4 to pi on 3 of let's have 1 over and remember that x equals a secant theta. So we would have a cubed secant cubed theta, make it longer, times the square root of x squared. Oh wait, shoot. Okay, that's fine. We'll just get that and get rid of that. We have square root a squared secant squared theta. A squared. Okay. And on the top, we have this. So we have a secant theta tangent theta d theta. Our differential here. Now, this we can use our trig identities. So we can the a come out of the square root, and secant squared minus 1 is just tangent squared. But we take the square root, so it's actually tangent. So we do pi over 3 of a secant theta tangent over a. Now we're going to combine the a cubed and the a here. So that becomes a to the 4th power. And we have secant cubed still, and we have our tangent theta and d theta. Now we can see, right, this expression can simplify a good bit. We can get rid of the tangents. And this simplifies to 1 over secant squared. And we have the integral coming from of 1 over a cubed secant squared theta d theta. Now, we see that 1 over secant theta is just cosine squared theta. And we might as well just take the 1 over a cubed outside of the entire integral. And okay, very nice. Now to integrate, okay, let's concentrate on this. Right. How would we integrate this? Well, we can do so using our power reducing identities. And in fact, we can derive this from our double angle identities. So let's do it on the side here. Say, okay, consider, we're going to consider cosine of 2 theta. 2. Well, we can isolate cosine squared x. It's cosine squared theta. So therefore, you see that cosine squared plus. Okay, so you go, okay, well, what is this gonna do for us? Well, if you're familiar with your integration techniques, this is much easier to integrate than that, because this we can integrate cosine 2 theta very easily, and these are just constants. So in fact, that's what we're going to use to integrate this, and this would be 1 over a cubed now we can just use our basic integration techniques, and we can just integrate it properly. So this becomes 1/2 theta plus quarter 2 theta. This is evaluated from pi over 4 to pi over 3. Okay, that is very, very nice. Now, well, what can we do? We just need to evaluate this. So this will just be a cubed times pi over 6 plus, this is sine of 2 pi over 3, which is root 3, which is so 1/4 times root 3 over 2, minus the lower bound, which we find is pi over 8 plus 1 over 4, and alt sine of 2 theta here is just pi over 2, so that you can close it off. And we're actually pretty close. So in fact, we're gonna go on the back here. Then we have 1 over a cubed. And let's just rewrite the expression, because why not? So we have pi over 6. And in fact, we can cancel some of this stuff out. So we have pi over, this is over 8. So this is root 3 over 8 minus pi over 8. And this is minus 1/4. Okay, very nice. Well, we see that all these have a common denominator of lowest common denominator of 24. So we have 24. So we have 4 pi plus 3 square root 3 minus 6. And, well, we can simplify and we arrive at our results. There. And we are done.